Hi, my name is Jürgen Sito from the University of Zurich, and together with my colleague Joel Scheuner, we will be presenting Cloud WorkBench, a tool for cloud benchmarking based on infrastructure as code. So, why we built this tool? In the market of infrastructure as service clouds, we have many providers offering a lot of services with different performance characteristics. In fact, they're so different, as a software engineer choosing the appropriate service for a particular application is quite a challenge. So the problem is that in cloud environments, we cannot systematically evaluate performance by hand. First of all, with a number of different providers and services, it just takes too much time. Secondly, errors in the process threaten reproducibility and therefore the validity of benchmarking results. To address this problem, we've built a web-based framework called Cloud WorkBench that automates the process of cloud benchmarking and allows defining modular and reusable benchmarks. Different to other approaches, Cloud WorkBench adopts the notion of infrastructure as code. In infrastructure as code, the complete installation and configuration of middleware, such as web servers, including its configuration files, is captured in provisioning code. The piece of code describes the desired state of a node, in our case a virtual machine in the cloud, and can be executed by standard DevOps tools such as Puppet or Chef. The whole toolchain has also been open sourced and is available on Github. Alright, now that we've got some motivation going, Joel Scheuner will guide you through the process of defining and executing benchmarks in Cloud WorkBench.
I'll now show you the key snippets of the code that is responsible for preparing the benchmark on a cloud VM. In a first step, the benchmark software is installed, and in a second step, the benchmark is configured to execute and integrate with Cloud WorkBench. The installation of the benchmark is entirely captured in the following code. In case we are on a Debian platform, we firstly update the package manager, and secondly, the provisioning tool automatically translates the command package sysbench into instructions for the respective package manager of the underlying system, such as apt-get install sysbench on Debian platforms. That's it for the installation. The most important code generated during the configuration phase is the following hook script that gets invoked when the benchmark is executed. For simplicity, we have omitted some basic imports and helper functions above. Starting at line 4, the shell command to execute the benchmark is constructed using some dynamically configurable command line arguments we will see later. The command is then executed, and the execution time is extracted using some regex pattern matching. This metric is then submitted along with another metric that is just the model name of the CPU of the Cloud VM under test. Finally, the Cloud WorkBench server is notified that the post-processing is completed. Once we have defined the installation and configuration of a benchmark in this way, we upload this so-called cookbook to the provisioning service. Subsequently, we can conveniently parameterize and manage our benchmark via the Cloud WorkBench web interface. Let's switch to the web interface. We now log into the Cloud WorkBench web application, and the dashboard reveals that this instance of Cloud WorkBench was already heavily used in the past for research purpose, having executed close to 20,000 benchmarks. We have already prepared a benchmark definition, and therefore, within the existing benchmarks, we search for sysbench. We can edit, clone, delete, execute, or view the benchmark. But because we want to revise some parameters, we create a clone of the sysbench definition, which we simply call sysbench version 2. The execution timeout ensures that previously acquired cloud resources are released, no matter whether the benchmark has completed its execution. This prevents costly resource leaks that may occur if something goes wrong during the execution. We set it to an hour. We currently support the Amazon EC2 cloud provider and Google's compute engine, but we can plug in other providers on demand. The main configuration and parameterization of the benchmark is accomplished in a so-called vagrant file. The first section covers cloud provider-specific configurations, and the second section refers to our previously defined benchmark cookbook. This Amazon EC2 cloud configuration specifies that our instance should be launched within a data center in Europe on a M1 small instance, already changed to a T1 micro instance, with a bare Ubuntu image. In the provisioning configuration section, we refer to our previously defined sysbench cookbook. The test mode CPU is fine, but we want to decrease the workload to 2000 because we don't want to wait for a too long time until the prime numbers are calculated. We also have the flexibility to add additional command line options supported by the sysbench utility. We can add the number of threads and specify that we want it to be executed single-threaded. Additional arguments can be specified simply via key value pairs. Once we're done, we save the changes, and now we want to execute it. But you may have seen before that some existing benchmarks were already executed more than 300 times. It would be cumbersome to do this by hand, so let's create a schedule to do this. Periodic schedules can be defined via the cron expression syntax, so we can create a schedule to automatically execute the benchmark at the quarter past, midnight and lunchtime every day of the month, every month in the year, and every day of the week. We activate it and create a schedule. But instead of waiting till midnight, we can also manually start the execution now. We are automatically forwarded to the execution-based view, where we can track the progress of the benchmark. After a short refresh, we can activate the live log refresh and see what's going on. Let's switch to the web interface of the Amazon cloud provider to verify that an instance is currently launched and in the state of initializing. All further events will be added to this timeline so that the experimenter can track each individual execution of the benchmark. The benchmark has now successfully completed and should have submitted new metric. Let's check this by navigating to the associated ratio scale metric time. Here we can see the result of the just executed benchmark. It took just 2 seconds for demonstration purpose. In summary, we have seen the key elements of the benchmark cookbook, the benchmark definition in the Cloud WorkBench web interface, and then the actual execution of the benchmark. We have already used Cloud WorkBench in a large-scale experiment where we have collected more than 33,000 data points on cloud infrastructure, and as mentioned before, the source code is available on GitHub, so check it out.